we're going to solve some triangles today. So solving means you go through that triangle and you find a number for every angle and every side that isn't labeled already. So this triangle up here, I'm going to just see what I have to figure out. I don't know this length. I can see it's across from the 90 degrees, so that's the hypotenuse. I'll label it C. I know this angle is 90 degrees, but I don't know this one, and I don't know this one. So I have three things I have to calculate here. So when you're trying to figure out where to start, you have lots of options. The first tool you have for right-angled triangles is the Pythagorean theorem. And the second set of things you have are the sine, tan, and cosine ratios. So the sine of any angle is the opposite side over the hypotenuse. The cosine ratio of any angle is the adjacent over the hypotenuse. And the tan ratio of any angle is the opposite over the adjacent. Now this gets abbreviated sometimes to help you remember as SOH. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA. Tan is opposite over adjacent. SOHCAHTOA. So if you hear somebody yelling that at you, it's because they're excited about solving triangles. So you've got your Pythagorean theorem, you've got these angle things here. What am I going to do? Well, I could use Pythagorean theorem to find that side. I could do that first. I could park the alpha here and try and put in the opposite and hypotenuse. I'd have to put in 12 over c. So it would look like sine alpha is 12 over c. Now notice that I have two variables in there. If you have two variables, that thing isn't solvable. Not yet. You'd have to get one of those numbers in order to find the other. If I try cosine of alpha, well, it's the same thing. I need the hypotenuse to do that. So if I tried to set it up, adjacent to alpha would be 10, hypotenuse is c, and you can see I have two letters in there, the alpha and the c. I can't proceed. Same thing's going to happen with beta. It's just a mirror reflection. 10 over c and 12 over c. I still can't use them. Tan. If I try tan for alpha, I get opposite, which is 12, over adjacent, which is 10. I only have one letter there, which means I can actually solve this thing. So, solving this, solving that, I've got two things I can do, so I might as well do them. C squared is 10 squared plus 12 squared. That means that c squared is 100 plus 144. It's 244. Square root of 244, which is maybe like 15.4. Yeah, 15.6. All right, so I have a length here. I have a setup for tan that I could finish. So tan alpha 12 divided by 10 is 1.2. So then I need to arctan 1.2. Shift tan 1.2. It's 50.19 degrees. was alpha, so that's here. Well, the only thing left to get is beta. Now, I have some choices. I could set up a tan using opposite over adjacent. That would get me the size of beta. I could set up a sine now because I have the opposite and the hypotenuse. I could set up a cosine because I have an adjacent and a hypotenuse. Or I could just keep in mind the fact that this and this and this all have to add to 180, and I can get it that way. When you're solving a triangle, once you get two of these numbers, the third one just pops out at you. You really have a choice of whichever tool you want to use. So how do you pick one? Well, it's a sort of pointed question. Do you trust your work? Do you believe that this answer is correct? Do you believe this answer is correct? They might be, they probably are. But if they're not, and you use one of these to calculate beta, then beta will be wrong because it had bad input. So if you can make a choice to try and use the numbers you were given, these ones in pink, to get that side, then you know you're putting good input in. You're not using stuff that may or may not have a rounding error or some sort of negative or number glitch in it that will mess up your answer for that last thing you're trying to find. So if I'm trying to combine a 10 and a 12 to get beta, I see an opposite and an adjacent. That's tan. So if I use tan of beta is its opposite side over its adjacent, I get tan of beta is 10 divided by 12 gives me 0.8333. Now you could just leave this as 10 twelfths and do 10 in arctan on that directly. It will get you more or less the same answer. And using the fraction is always better because there's no rounding error. I'm sitting at 39.81 degrees. Okay, so fact check myself. 50 and 39 is 89, and 0.19 and 0.81 is an extra 1. So that would give me 90 degrees plus 90 is 180. All the angles in the triangle add to 180 degrees, so I know that I've done this one correctly. Okay, so I'm going to clear this off, and I'll try and go like a little quicker with an example that has slightly different input than what we have there. We have a new example here. I still have two sides labeled, but instead of the legs being labeled, I have a leg and the hypotenuse. So I go through and I look at what letters I need to solve. I need one of these legs, and I need this angle, and I need this angle here. All right, so tools, I've got Pythagorean theorem. And if I started filling numbers in, that's C. Don't know A, means that B is 9. I only have one letter left, which means I can solve this. I can do the algebra on this and the arithmetic, and I can actually get a value for A. So that's good. A is taken care of. Want to try these trig things, so sine of, let's try alpha, would be its opposite side over the hypotenuse. That's what this says, sine is opposite over hypotenuse. That has exactly one letter in it, so I can use this to solve for alpha. But I tried the same thing for beta using sine. Opposite from beta is a over 13. This has two variables in it, so I can't use it to solve. So I'm just going to scrub it off my screen. Next trig thing is cosine. So cosine, I already have alpha, so let's try beta. Cosine of beta would be the adjacent side over the hypotenuse. Well, that only has one variable in it, so I'll be able to use these three things to solve the three variables in my triangle. So 13 squared is 169. 9 squared is 81. Subtract this from both sides. It'll be 88 equals a squared, square root 88. It's going to be like 9.1. Oh, 9.38. All right, so I have a side here, 9.38. I just check myself. The hypotenuse has to be the longest side. This is less than 13, so I've done it right. Here, I need 9 divided by 13. This gives me 0.6923. Got arc sine the other side. We have 43.813 degrees. I've got an angle here. And for beta, cos of beta would be 9 divided by 13. I already have that number there, 0.6923. So I just have to arc cos it. Divided by 13, and then arc cos, be 46.187. I have an angle up there. Again, fact check yourself. The largest angle is across from the largest side. The smallest side is across from the smallest angle. The medium size is across from the medium angle, so everything worked out. I'm going to clear this off and try another one with different input again. So another triangle. Note it has three pieces of information again, but instead of two sides and an angle, this one has two angles and one side. So the tools I have available to me still haven't changed. First one would be Pythagorean theorem. So c squared is a squared plus b squared. If I try filling that in, that's c. Oh, I forgot to label my variables. See, what don't I know? I don't know this side, and it's not the hypotenuse. I don't know this side, it's not the hypotenuse. And I don't know this angle, so there's alpha. Okay, so a squared, I don't know that. B squared, I don't know that either. So this expression has two variables in it. I'm not going to be able to use that to solve this triangle. So onto my SOHCAHTOA. Sine is opposite over adjacent. So I know this angle here, so I'm going to use that one. Sine of 32 would be the opposite side, that's B, over the hypotenuse, 27. Now, I have one letter there, which means I can use this to solve for B. That's good. Next ratio, cosine of 32 would be the adjacent side, that would be A, over 27. All right. And my tan ratio, tan of 32, would give me the opposite over the adjacent. That has two variables in it. I'm not going to be able to use that one. Now, if you notice up here, I don't have anything for alpha, except I know two angles in my triangle. So 180 has to be 32 plus 90 plus alpha. So 180 is 122 plus alpha. Kick that over. It's probably on my face. 58 degrees. No. Draw a number badly. Don't try and fix it. Just erase it. Do it again. All right. So between these 5 tools, I was able to figure out a model that would solve everything. So up there, I've got 58 degrees. Need to finish this here. Sine 32 gives me 0.5299. So I need to break this division by 27, multiplying both sides by 27. That gives me 14.308 if I round. And cosine of 32, 0.8480. So again, I need to break this division by 27. And multiplying both sides. And I get 22.897. All right, so B was 14.308. A was 22.897. I'm just going to self-check here. 27 is the biggest of the 3 sides, and it is across from the largest angle. That's good. 14.3 is the smallest side. It is across from the smallest angle. That's good. So I know that I've done all this correctly. So I just have one more example where we know an angle and one of the short sides, and then I think you're good for the practice problems. Okay, so let's go through and label what our unlabeled sides are. I don't know the length of the hypotenuse. Let's see. I've got one of the legs, but not the other. Let's call that B. Then I have this angle, but not that one. So I need alpha. All right, so tool number 1, Pythagorean theorem. I don't know C. I know A. I don't know B. So 2 letters in there, I'm not going to be able to use that. So start with the sine ratio. Sine of the angle I know would be the opposite over the hypotenuse. That would be B over C. That's, again, 2 letters I don't know, so I can't use that one. Cosine of 72 would be the adjacent over the hypotenuse. 6 over C. Well, that one's good. I only have 1 letter in it, so I'm going to be able to solve for C using this. I've got tan 72 would be the opposite over the adjacent. That would be b over 6. Try and make it so you can tell those apart. It's only one letter in there, so I'm going to be able to use this to solve for b. And 180 degrees has to be 90 plus 72 plus alpha. That only has one letter in it, so I'm going to be able to solve that one. Let's start on this end. 90 and 72 is 162. Kick this over. Gives me 18 degrees for alpha. Cos, I'm just going to squeak over here so I have some room. Actually, maybe I'll do the tan first. Tan 72 is 3.0777. And I have to clear out this dividing by 6 by multiplying the other side. I end up with 18.4661. And cosine of 72 is 0.3090. Oh no, this is that weird one where the variable's in the bottom. Well, that's okay, you don't need to panic. Multiply both sides by c. And once it's up there, I have to break this multiplication by dividing both sides by 0.3090. Break that upside down. Times 6 gives me 19.416. All right, so C was 19.416. B was 18.4661. Alpha was 18 degrees. So again, self-check. 19.416 is the biggest of the three sides, and it is across from the biggest angle. 6 is the smallest of the three sides. It's across from the smallest angle, so I know I've done all this correctly. So the moral of the story here is that you have 5 tools for solving things inside triangles. And sometimes when you set them up, you end up with 2 letters left in your formula. And when it does that to you, you can't use it because you don't have enough information from that particular tool. But don't panic, because there will be other tools that do have enough numbers filled in that there's only 1 letter left for you to solve. So between Pythagorean theorem, the 3 pieces of SOHCAHTOA, and the fact that all angles in a triangle have to add to 180 will allow you to solve everything about every right angle triangle you ever come across.